Welcome back. We are still in system of equations, and one of our learning objectives is to learn how to solve system of equations with elimination using addition and subtraction. We're still looking for a solution that makes both equations true. We're still trying to isolate one variable and solve it, and then plug that solution back into an equation and solve for the other variable, which is what we did in the last one, the substitution method. The steps to follow. Step 1. Write the system so that like terms with the same or opposite coefficients are aligned. That way when you add them, they're already lined up. Add or subtract the equations, eliminating one variable. You want to eliminate one variable and then solve that equation for the variable. Take the variable that you solve for and substitute the value from this step 2 into one of the equations and solve for the other variable. So if you have x, you're going to solve for y. If you have y, you're going to solve for x. Write the solution as an ordered pair. Remember, it has to be an ordered pair. An example, we have this system of equations. Step 1, align the opposite coefficients. Well, if you notice here, we have a positive 6 and a negative 6. They're already aligned. We don't have to do anything. Step 2, add the equations. So when we add them, 4 plus 3 is 7x. These drop out. 32 plus 3 is 35. Solve for the variable x, divide by 7, and we get 5. Step 3, substitute the x value into either equation to find the y value. I did it both ways. Here it is plugged into this first equation. Here it is plugged into the second equation. Doesn't matter which equation you use. If you're doing the math correctly, you should get the same answer, which is y equals 2. So our answer is 5 is the x value and 2 is the y value. Another example here. In this one, they're not aligned. So in step 1, we're going to align them so that the x's are aligned together and the y's are. Step 2, we add them and eliminate a variable. Here, the x's drop out. So we're left with 12y equals negative 12, so y equals negative 1. Plug that back in, and we're going to plug in negative 1 for the y. You can use either equation. I use this one, and we solve for x, and we get 2. So that ordered pair and solution is 2, negative 1. You do have to watch for this type of problem. Step 1, align them. Okay, we align them. We see we have 2 and another 2t and another positive 2t. If we add those, we're going to get a 4t. That doesn't help us a lot. But if we multiply each term in the second equation by negative 1, which is what I did right here, I now have opposite coefficients, which will drop out. So when I go through and add these after multiplying by the negative 1 and make sure you get each term, I get r equals 4. Plug that back in and we solve for t, and it is negative 7. So the answer is 4, negative 7, and I did make a mistake. That's supposed to be a negative 7. I do have extra credit on this one. I made a spelling mistake on one of the slides. The first 2 students from each class who can come and tell me what that spelling mistake is gets the extra credit of 5 points. Until next time, see you.